Let's start with a modification to the 1.8 fuel-injected engine. Audi and Volkswagen engines are all designed to return good fuel economy and to minimise pollution of the atmosphere. Now, this means very accurate control of the fuel-to-air ratio throughout the engine speed and temperature ranges. However, one major consequence has been poor cold acceleration characteristics, particularly on fuel injection engines. To overcome this, cold acceleration enrichment has been introduced on most of the fuel-injected range.
The system injects a short burst of additional fuel via the cold start valve for about 0.4 of a second during the acceleration phase, when the engine temperature is below 35 degrees centigrade. This fuel is injected only when 3 switches are all closed at the same time. Firstly, the thermo time switch senses the temperature of the engine. It is only closed when the engine is below 35 degrees centigrade. Secondly, the throttle valve switch only closes after the throttle valve has just begun to open. Thirdly, the diaphragm pressure switch closes briefly when the pressure in the inlet manifold increases. So, as soon as acceleration begins, the contacts in the throttle switch close. An increased pressure, or reduced depression, is then present on the engine side of the throttle valve. This acts upon the diaphragm in the diaphragm pressure switch, closing the contacts. Providing the engine is below 35 degrees centigrade, an electrical circuit is completed by the thermo time switch, causing the cold start valve to open and inject a burst of fuel into the manifold for about ½ a second. The simplest way of testing this system up to the cold start valve is to connect a test lamp with a power rating no less than 4 watts between the connections of the cold start valve connector block. With the engine running at a temperature below 35 degrees centigrade, open the throttle quickly. The lamp should light briefly. Now warm the engine to above 35 degrees centigrade and open the throttle quickly. The test lamp should no longer light. If these tests work, the electrical components of the cold acceleration enrichment system are functioning correctly. If either doesn't, then refer to the workshop manual. The system on some 5-cylinder fuel-injected engines differs slightly in that the air supply to the diaphragm switch is cut off by the thermopneumatic valve at about 35 degrees centigrade. In the past, during the idling phase of the 1.8-litre fuel-injected engine, uneven running was found to result when electrical consumers were switched on. This engine, from model year 1985 onwards, has been fitted with an increased idling speed valve. It controls the engine speed at idle should it drop below 700 RPM. Additional air is fed past the closed throttle via this valve. This additional air increases the engine speed, resulting in even running characteristics. At about 1050 RPM, the system is switched off and the valve closes. A control relay determines the switching points of the valve using speed information obtained from terminal 1 of the coil. This system can be checked simply by reducing the engine speed to below 700 RPM. Providing the system is functioning okay, a click from the valve as it opens can be heard, and the idle speed will rise. If there is no increase in the idling speed, refer to workshop bulletins filed with the workshop manual. However, for this system to operate correctly at all, it is essential that the basic idling speed is set in the right sequence. With the engine oil above 80 degrees centigrade, the ignition and valve clearances correct, and the crankcase breather hose disconnected, clamp this hose. Making sure that all the current consumers are off, adjust the idle speed in conjunction with the CO to 900 RPM using the air volume and CO adjustment screws. Now remove the clamp. There should be no rise or fall in the engine revs. If there is, further investigations should be carried out.